somewhat about EDI, which stands for Electronic Data Interchange, which is basically what terminals have been using pretty much up to now to communicate with other large corporations. And I will talk about some of the disadvantages of EDI. And then I will go into XML and we'll talk about other types of technologies that could be used to do the same thing that we're using EDI for. And I will talk specifically about some attempts to kind of convert, in a way, EDI and mix it together with XML. And so XML conversion is one of these, EDI is another one. And then I will use this as a background to go into the actual communication model at the ports of LA and Long Beach right now. And then we'll look at what makes most sense for the terminals at this point in time, given the infrastructure that they are having and given what is available at the ports. So it doesn't make sense to just talk about in abstract, they should do this, if they are actually already doing something else. So it makes more sense to see what they're doing and trying to say, well, what could they do to make this even better? And so that's basically an outline of my talk. Okay, so let's begin with an introduction. So the bottom line is that currently terminals mostly use EDI, Electronic Data Interchange, to communicate with other large companies. I'll tell you in a minute a little bit more about EDI, what it actually is and how it works. But for now, let's leave it at that. This EDI is basically a way of sending documents from one partner to another partner. So what EDI does is it takes the data that is contained in a document and turns it into a stream and then sends that stream to the other partner. And then the other partner needs to interpret the data that it receives and needs to kind of take every item it gets and puts it back in the same place where it used to be in the original document. And this is how large companies communicate when they send data to each other. The banks are still doing the same thing. And this format is very compact. In other words, you're not really sending anything additional to the data or very little additional information. But because it's so compact, it's also difficult to maintain and extend. It works well as long as the partners can agree in advance what they want to talk about and exactly what each item means to each one of them. But if you want to make any change or if you have anything unexpected happening, then EDI just quickly falls apart. It's just not something that makes much sense to use in that kind of context anymore. Also, it only allows for computer-to-computer interaction and communication. In other words, it's not really human readable. I mean, not really human readable doesn't mean you can't read it, but it doesn't really make sense to you unless you have in front of you the form from which the data was taken that is now basically sent over to your business partner. And because it's so expensive and so difficult to maintain, it doesn't really include smaller companies and smaller partners because they usually cannot afford to invest into EDI. We went to a terminal at the port API and they were telling us they just have an EDI department of several hundred people that do nothing else than just maintain EDI communication. So it's very labor intensive. And the final, maybe fatal weakness of EDI, especially these days, is probably that it lacks exception handling. Meaning, if anything happens that you did not foresee, you cannot use EDI to communicate that special event, that new event, that extraordinary event. So for example, if you send a manifest using EDI, and the manifest says, okay, these are the containers you should load onto a ship. But if now it turns out that one of the containers, for some reason, is not there anymore, then there's no way using EDI to communicate that to your partner. And the terminal will have to sit there and try to figure out in other ways what to do with this particular container. So these types of exceptions are not handled by EDI. So in a contrast with EDI, we have what's called the extensible markup language. The extensible markup language, called XML, has become very popular in recent years as a standard for web documents. And this standard, in certain contexts, in certain areas of the economy, has become popular to be used for business-to-business communication. Now, what makes XML different from EDI? Well, the first thing is that XML-based communication can be accessed and can be read and understood by any web browser. So you don't need to have a special parser like you would need with EDI to understand what is actually said. The second thing is the XML documents, they do not just contain data, they also contain information about what the data actually means. So semantics, right? So it's syntax and semantics. It basically also tells you this item represents this. And if you want to define something new, you can do this within XML very easily. You don't have to go back and wait for some standardization organization to say, okay, since you guys want to talk about this, now we need to add this to our standard, and once we have done that, you can use this. No, it's a totally different viewpoint. If you want to communicate a new meaning, you just define that meaning within XML, within the document, and then the other side can understand it because it has the definition right there, or they can easily look up what the definition of that particular new item is. So that's one of the big advantages. You pass on information not just about the content, but also about the structure of something. In other words, meaning. Because of that, because it's accessible through a web browser and it's much more flexible, it appears to be cheaper to implement, and also it appears to be much more easily accessible to smaller stakeholders, like for example a small trucking company. That if you know we would have this XML-based communication, we could go to a web browser and get information about the status of a container through the web browser, for example. It doesn't need to have capabilities of being able to understand EDI communication or anything like that. So the question that arises because of that is now, so how could we best use this new technology, XML, at the ports of LA and the ports of Long Beach? In other words, what best makes sense for them to do? And that was basically the question we wanted to answer with this particular project. To look into that. So let me give you some more motivation why this project or this question makes sense. Well, it turns out this is not just an academic question. It's also that at the terminals, they are now working on, they are aware of this problem to some extent, that they have problems with communication, right? One item or one issue where you can see that is, for example, that they have instituted appointment systems, right? They realize that if they potentially have a working appointment system, they can make things more efficient, you know, less waiting, less waste, and so on and so forth, right? And also, when we talk to the terminals, we realized, and you just have to do a Google search now and you can easily see the same thing, that a lot of terminals are right now in the process of installing very sophisticated so-called terminal operating systems. These are computer systems that allow the terminal to supervise anything they are doing, right? For example, they monitor all the equipment, they monitor the people who are working there, they monitor all the containers and things like that. And so terminals have realized that this is something that really helps them to become more efficient. And so it shows that you know, they are interested in this particular area in terms of improving their efficiency, improving how they operate, how they do things, how they communicate with others. So the question is, coming back, this is the same question I asked earlier, how can this be best extended? You know, what would be the next step, so to speak? So before we go there, let me give you some overview over EDI and XML and tell you a little bit more about these protocols, these methods of communication. So EDI basically does nothing else than just implementing a standardized, structured, and normalized way of sending electronic messages from computer to computer. So it's standardized, it's structured, and it's normalized. And the first problem that arises is that worldwide, they are basically in the shipping industry, there are two different standards that are used. In the United States, they use a standard called X12, and in the rest of the world, they use a standard called EDI FACT. So that already means that, you know, if you want to communicate with a terminal using EDI, you either have to use X12 or EDI FACT. So you have to not just decide what are you going to use within the standard, but you already have an option between two different standards. Like I said earlier, EDI itself, and I have some examples later, is not human readable. I mean, you know, you can read it obviously, but without any additional information, you will not know what something means. You need to talk to the sender, if you're the receiver, and ask, so what does this mean? What is this? What does it represent, right? It's not contained within the data stream. And because of that, as I said already before, poor exception handling, and we'll see some examples of that later. So what's the problem with EDI? Well, the first problem with EDI is the setup of communication, right? How do you set up an EDI communication? Before you can set up an EDI communication, the two parties have to first negotiate an agreement. So both companies have to have some kind of EDI department. And this EDI department, they have to get together, maybe over the phone or meet in person, and they have to decide, okay, this is the part of the standard that we want to use. In other words, these standardized documents are valuable for us. But then maybe we don't want to use everything in the standard. So if we want to take something out of the standard, we have to agree on that. Right? So we have to agree in advance. Because otherwise, since EDI is basically just raw data, if I just send you raw data and I don't know, and I just follow the standard, but you have taken something out, then I will not be able to understand what you're trying to tell me. Or I will mix things up. I will think what is the number of orders is the price of an item, or something like that, right? Because in EDI, it's not going to tell you this is the price and this is the number of orders. It's just going to throw at you some numbers, and then you have to know how to interpret these numbers, right? So therefore, they have to get together and read in person. Another thing is the standards are not really set in stone. They are often modified and diverge. Why? Because of the whole issue that, you know, it's just so limiting, right? That, you know, somebody new comes in and says, well, but I need this. And then there's another push to say, oh, we need to extend the standard to allow them to do this type of communication, or to say these kinds of things to each other. Because of that, because it's so complicated, there are also a lot of companies out there who are actually selling EDI packages. So what you can do is, if you can afford it, you can just hire an outside vendor who takes care of all this for you. You just tell the outside vendor, this is the business data that I have. And the outside vendor will basically take care of converting your business data into EDI documents if necessary, takes care of the communication itself, and then basically unwraps the EDI communication on the other side and turns it back into something that business software can understand. So that can be done, but it's expensive. And so the commercial vendors, what these packages will do, they will do the mapping between the standard and the internal file format. They will manage your trading partner relationships, and they will timetable and automatically run the message transfer. So this can all be done by some outside vendor, but obviously you have to pay for it. And if you're a small mom and pop shop, or with just a few drivers, let's say a trucking company, usually this is not something you can do, right? It's just too much expense. So why is EDI then used in the first place? Why is not everybody going somewhere else and using some other technologies, or using the internet in a general sense to transmit business information? Well, it has historical reasons. Basically, EDI became popular in the late 1960s as a replacement for manual data entry. At that time, this was something revolutionary, right? Suddenly, companies were able to send each other information that didn't have to go to the mail, and it didn't require manual data entry, and where people could make lots and lots of mistakes when they were entering manually. Now, suddenly, you could send your documents electronically to another company, to another computer, and it didn't really involve humans anymore. And so at that time, a lot of companies, larger companies especially, invested a lot of money into EDI. And there have been some studies that where people were asking, so why are they not, moving on to something else? Well, and the outcomes of these studies were basically, they were saying, well, it's because they have become so convinced of the benefits of EDI that they just see moving away from EDI as just a business expense, and they don't want to incur that, and they say, well, let's just leave it as it is. We know exactly what we have with EDI, so why bother? So at that time, it was popular, and it became popular because it reduced transmission errors, but because of its cost, it's really only used by 2% of the world's businesses. But many of the large ones, and especially large ones like terminals, rail operators, carriers, shipping lines, these types of companies, multinational companies usually. So why is it used mostly by large companies? Well, because as I already tried to describe, the setup process is very expensive. It takes a lot of time, and because it takes a lot of time, it takes a lot of labor, and so it's labor intensive, it's expensive, it costs a lot of money. You have to map your internal data formats, how you store your data internally to whatever EDI wants you to do before you can send it somewhere else. And if you decide not to do that internally, but you hire an outside company or an outside contractor, then you get locked into this specific vendor's proprietary system and to his or her value-added network, right? So you have no more flexibility, and that increases your costs. So why EDI? Well, mostly because of historical reasons and because it's working. But and companies see any change away from EDI as just too much of an investment. I think that's what it is. And they don't really see the benefits enough. So what could you do to avoid EDI? Well, one thing you could do is you could try to create your own parser. In other words, you could try to kind of take your EDI document and turn it into something else and send it in a different format. Let's say, for example, in that XML form. But to give you an idea how difficult that is, let me show you two messages in EDI. And these two messages do nothing else than basically just give the address of my office at Cal State Long Beach, right? So first one is a message in X12, and in X12 you have these what looks like numbering of lines, N1, N2, N3, and N4, and then there is the name of the university, there is the name ADI customer, then there's a street address, and then there's a town, and then the zip code, and then the country. In EDI fact, what you see is you have this what looks like a preamble, and then you have basically the data just separated by plus signs, and that's it. So when you look at this, you probably can realize very quickly that there's no information here about what these things mean. Now, this type of information is obviously human readable because we know what it means, because we understand the difference between the name of a town and the name of a street, and we understand the difference between a zip code and a country code, right? But now imagine this is business data. What is business data? Mostly these are just numbers, some kind of numbers that are sent, right? In a manifest, a number of a container, a weight, and what have you, where it's supposed to go, and so on and so forth. It's all coded, right? And then you get something like this, which are basically it's just a sequence of numbers separated by plus signs. So now if you, for example, leave something out, but if the other side thinks this next item represents this, then they will interpret it as that no matter what. So in other words, if you make a mistake and something is left out, say for example the street is left out, then Long Beach would be interpreted as the street name, right? Unless you have agreed with your partner in advance that you wanted to leave that out, right? And this is now the case for any type of business document that you would send using EDI, right? So very labor intensive. The two parties always have to get together and make sure they exactly know what they're talking about. If one of them makes any little change, the others need to be aware of it, otherwise they cannot understand it anymore. They will misinterpret it, and everything will become shifted in a way, right? So it's not really something what you would consider something that is can be easily maintained. It's labor intensive. But on the other side, it's compact, right? Why is it compact? Because you're really just sending the data, that's it. You're not sending any kind of information about structure or anything like that. And so because of that, it only really works if you have very strict standards that they'll tell you, if you send something like this is what this is supposed to mean. And then everybody has to adhere to that very, very, very strictly, right? You can't just go away and say, I make this change because I want to send you this now, unless the other side is aware of that. So creating your own parser is basically would require you to understand the EDI document completely, know what everything means. But then the question arises, what does that really buy you? You're still then basically using EDI, and you're still stuck with the same problems that EDI has anyway, right? Any questions so far? So from the example on the previous slide, you could see there's no information about the structure of the document, what things mean, right? It's just raw data that is sent. So the sender and receiver have to agree in advance on the meaning of what they are sending in this standardized document. If they are leaving something out, if they are adding something additional, things like that. Also, if you don't use a field, everybody who receives that message has to be aware of that. You can't just leave something out and not tell the others. They will not understand anymore what you're talking about. They will interpret, like I said, a street name as a town name or something like that. Now, obviously, in that case, if somebody would look at it, they would say, well, I can see that this is a street name, but you know, this is supposed to be computer-to-computer communication. So, you don't look at that anymore. Also, business software cannot understand native EDI documents. You need mapping. You need to, the business software that you run in your company doesn't understand EDI, so you have to have some kind of way of mapping your business document, your database stuff, onto these EDI documents. And so you have to have human intervention and supervision, because it's not always the case that everything runs smoothly. There was always chances something is not there, or something's missing, things like that. And then you need to have humans go in and talk to their partners on the other side and say, okay, we have this problem, we need to deal with this, we need to make this change, so on and so forth. And so that's why they have these EDI departments of hundreds of people in these companies. So you have to have an EDI department or hire an outside contractor. But on the other hand, we shouldn't forget the positive side. It's very effective for business transactions that will involve very few or no exceptions, right? If everything is always the same, or let's go back to the example, right? If everything is always the same and you just send these data streams and you never need to make any changes, that's very effective, because you're really only sending what you absolutely need to send. You don't send anything additional, anything further. It's just what is necessary, and that's it. You don't add additional information to it. But the moment something unforeseen happens, you're in trouble in the sense that you have to go back and you have to in a way start from scratch, and you have to get involved. Humans have to get involved, and then basically this becomes expensive. So if everything goes well, you don't need to have human intervention once communication has been set up, right? If there are no exceptions, nothing, everything is just always exactly the same, you can use it very nicely. So you get speed up, number of errors is reduced, because no more manual entry, nobody has to read a document anymore and then enter it back into the database or something like that. Everything is compact, it goes directly from computer to computer. But like I said before, only used by a small number of partners because it's just so expensive and so cumbersome. And in the case of terminals, it's used for the transfer of manifests between carrier and terminal, rail operator and terminal, and customs and terminal. That's what EDI is these days still used for, right? So before a ship comes in, a week before, they will send an EDI document to the terminal that contains all the information about that ship, what containers are on that ship, where they're supposed to go, what they are supposed to do with them, and so on and so forth. So this is all done using EDI. So now let's move on and let's talk a little bit about XML. So what is XML? First of all, XML is a text-based syntax standard. So it's all text-based. You can look at it, if you know how to read it, you can understand it very easily. And as I said before, it allows you not only to specify the content, but also the structure of a document. So you don't have that problem that you had with EDI anymore, that basically you're just sending data and you have to know in advance what the data means. But you can send meaning together with the data. You can communicate to the other side what this actually is supposed to be interpreted as. And that makes things obviously much more flexible. But on the other hand, you also have to include much more data, right? It's not as compact, obviously, as EDI, because you have to send all that additional information together with it. And this is also supported by web browsers, so any web browser can understand it. That makes it very accessible, right? You don't have to have any special equipment or anything like that. A truck driver could just have an internet-enabled cell phone and look up the status of a truck right there. If it's accessible through XML, you don't need to. He doesn't need to be logged into some kind of EDI communication or anything like that. There are also already around some XML messaging standards for e-business. Some examples, I'll just list them here. I don't want to really say anything in detail about any of these, this is just for completeness reasons. One of the better-known ones is RosettaNet. There's BizTalk, that's a Microsoft thing. So basically what they do is they sell you a whole package that allows you to use, it's based on XML, that allows you to use XML basically for business communication. So the next idea would be to say, we have EDI here, we have XML over here. What if we use XML to send EDI documents? In other words, what if we just, instead of trying to get rid of EDI in the first place, what if we just take EDI and then add to it in a way this additional information about the meaning of things so that we get more flexibility? And this is basically what's meant here by using XML to transmit EDI. Traditionally, EDI documents are exchanged using FTP, which is the file transfer protocol, or in the case of EDI-INT, which I will talk about in a second, AS2, which is basically using the internet in a way. And they are basically exchanged between enterprise resource planning servers, so large computers, essentially. Right? So now, what if we use the internet, in particular XML, for this transmission? Instead of just using, these value-added networks that you need to pay money for to a vendor to be able to access them, why don't we just open the box and we use the internet and we take our EDI documents and we transfer them into XML documents, basically. BizTalker, for example, allows you to accomplish this transfer between EDI and XML, the Microsoft thingy. So you just pay for the license, and then you can convert between your EDI documents into XML, and then you can send XML, and it becomes more accessible. So that would be one way of attacking this problem. There is also this so-called internet-based EDI, where you do the transmission of your EDI documents using internet protocols like HTTP, which is what you use usually when you access some websites. FTP is the file transfer protocol, and SMTP is the mail protocol. So you could also send these messages using email, right? So and if you do that, then it's called Internet EDI, because now you're using the internet to transmit EDI messages instead of some kind of private network of some kind of vendor. Then there's also what's called basic XML EDI, which basically means you take your EDI messages and you represent them as an XML document, in an XML document. In other words, you translate basically the EDI into XML and then you send the XML. And what you gain by that is you get additional flexibility because it becomes more accessible because it's now an XML document. But on the other hand, it's also labor intensive, and you don't really remove the underlying problem of EDI in terms of that you can't really handle exceptions that well, that it doesn't handle exceptions well, because all you do is you take EDI and translate it into XML, but it's still EDI basically. It's just EDI in a different language. And then there is also what's called collaboration XML EDI, where basically you go one step further. You don't just translate EDI into XML, but where you implement whole business processes in this way. So, if one company needs to do one thing, and to do that it needs to communicate with another company, then you implement the whole transaction basically. So from the beginning to the end, using XML. What used to be just an EDI communication becomes now an XML communication, and it implements a business process, right? Basically, for example, making a decision about a container would be such a business process, right? Whether to load it or unload it or things like that. And that would be then implemented like that. So it's like one step further. It includes, it's not just now taking care of the communication, but also of the business process itself, the whole business process, from beginning to end. And then there is also, I mentioned this already before, EDI-INT, which is called EDI, stands for EDI over the internet. It's a little bit confusing, I admit, because there are all these different names swirling around, and sometimes they mean something different, sometimes they mean something similar. I mean, if you just take out of this talk that there are these attempts to basically open the box a little bit with respect to EDI by turning it into XML documents, I think that's good enough. So EDI-INT is basically a working group of the Internet Engineering Task Force. And what they wanted to do is they wanted to have some kind of standard that allows you to securely transmit EDI messages over the internet and XML data over the internet. And their goal was mainly they wanted to get rid of these expensive value-added network. A value-added network is basically a network that is created or is maintained by a vendor that you can only access if you give money to that vendor, if you pay money to that vendor, then the vendor lets you access it, right? And so that's obviously an expensive thing because you have to give money, you have to pay money to the vendor. And they are saying, well, we have the internet, everybody can access it. We want to use the internet instead. But if we want to use the internet instead, we need to make it secure because anybody can access the internet. Any hacker, anybody has access basically to it. So if we want to open the box, we need to address the issue of security here. And so this is their proposal. EDI-INT stands for that particular proposal. And some major retailers are going in this direction. For example, Walmart, right? They are investing in this direction. They want to use the internet. They want to get rid of the middleman, so to speak, namely the contractor that maintains the value-added network, that private network that they would have to use to send their EDI documents. But with all this, there's a big caveat. There's still some security concerns that remain. It hasn't all been resolved. Often, if you really want to have security, you need to go back to what's called a VPN or virtual private network. In other words, it's as if over the internet you're having a private network, meaning, and that is usually accomplished through encryption. So you encrypt everything so nobody else can access it. Or you even build a closed network, right? So it's also not really ideal, and I would say it's certainly not ideal for our terminals. Okay, so this hopefully should suffice as some sort of high-level overview over EDI and XML. So my idea was, my goal was to introduce you to the problems with EDI and also give you an idea of some attempts that were made to mitigate these problems by moving over to XML. And the thing to keep in mind is just that EDI is bad at handling exceptions, and XML basically adds additional information to a data stream about the meaning of what is actually said. So now let's go to the ports themselves, and let's look at the communication model at the ports. What we have at the ports is basically what's called a bilateral information model, which means that information is essentially exchanged in a bilateral manner. Meaning we're having information exchange using EDI between a rail operator and the terminal, and we have information exchange between a terminal and the shipping line or carrier using EDI. So they exchange the information bilaterally. Another model would be a centralized model where we would have one broker that would hold all the information, and then the different parties would exchange information through the central broker. But at the ports we don't have that. We have a bilateral model. Yes?
Electronic companies, trucking companies don't use EDI?
Oh, trucking companies, yeah, only to a very small extent. Only the really large ones can use EDI. They don't really use EDI. No. And that was a part of the problem because they're kind of locked out, right? They use it mainly with the big boys basically because they can afford to have these EDI departments or pay for an outside vendor that deals with their EDI communication, right? While for the smaller trucking companies, there's just no way, right, to do that. So now what else is happening at the ports? What's happening at the ports, as I mentioned earlier already, is they started installing new terminal operating systems. And I want to spend a few minutes to talk about these operating systems because they are very important for what I will recommend later, because they have some capabilities that actually, I think, are very well suited to deal with this problem, the problem that I've been describing with EDI. So one of these fancy new operating systems is called Navis-Sparx N4. I'm not trying to here advertise for that operating system. I'm just trying to describe to you what's happening at the ports. For example, the AIS, when we were there visited them, they just had installed that operating system. And I just Googled it a few days ago. A lot of other terminals around the world are now, or have just also installed this particular operating system. So this is what I just said. So what's the deal with these operating systems? What do they do? Well, they are supposed to be highly configurable so that you can actually solve problems at the core. So the idea is you don't want to have something that you install that tells you how you're supposed to do, be doing things, but it should be something that you can configure and change so that if a problem arises somewhere, you can use your computer system, your operating system, to solve that problem. That's the idea behind these operating systems. So they're supposed to have this flexibility, right? To actually, on the fly, be able to address a problem that arises and then find a way using your system, your computer system, to solve that problem. And these systems are also generally fully integrated from gate to yard to vessel. So they know everything in a way, right? All the information, anything that happens in the terminal is basically represented somehow, somewhere in that system. So nothing is excluded. And they can also be used if, you know, the terminal operator is not just owns one terminal, but several terminals. You can even have the system integrate several terminals together. So you can have one big system that monitors all your terminals and knows everything that's happening at all of these terminals at any point in time. So it's very powerful. So at the same time, it's also relatively easy to maintain and use because it includes a nice graphical user interface. That's what I mean here by Java-rich internet application. So it's no command line operations anymore. You know, you don't have to have like a, you know, enter everything in text, but you have your graphical user interface. You can see your containers. You can see everything. So it's easy to use. It's easy to train your employees to use this particular type of system. And you have the ability to include other applications. And you can do that using internal developers, consultants, or you can even hire the company that built the operating system. So in other words, it's so flexible that you can write new code and you can add it to your operating system if you want to, and then it becomes part of the operating system. So it's not a closed system, but it's more of an open system where you can now, you know, look at what you need, and based on your needs, you change that system. So this has to be adaptable, and the reason why this works is it's done using what's called a system called Groovy. Basically, it means it has scripting capabilities. So you can write little scripts, little programs that then basically connect to your operating system and basically become like part of the operating system. So it's very flexible. So for a terminal, that means they can just hire a few programmers and that need to maintain the system, and also to kind of extend it in case there is something that comes up, you know, that they hadn't foreseen, or there's a particular situation, and so on and so forth. So there's a lot of flexibility there. So adaptation to local requirements with such a system is actually relatively easy. So let me tell you some of the features of this particular operating system. It allows you to do, just to show you how powerful it is, it allows you to do real-time optimization for equipment work assignments, meaning you can basically have it figure out how you should use your equipment to be most effective, for the equipment to be most effective. And that can be done in real time. It can optimize your yard management. It can optimize vessel planning, so how to, you know, store the containers on the ship. It has a K commander. It can monitor in real time the vessel and the crane. And it also allows you to deal with EDI. It has the capability of basically doing the transformation between business data and basically your EDI documents. And most importantly, it has what's called web service capabilities. So this is the thing that interested me when I saw that for the first time. Because web services are basically a way of using the internet for computers to interact. So they do actually something quite similar to EDI, but they do it in a way so that you don't just integrate, you don't just exchange documents, but you actually integrate processes. And I'll talk about this a little bit more. So the bottom line is that these operating systems already include this capability to use web services and to access them through web services. And I thought that was interesting. So what are web services? Well, EDI implements document exchange. So that's all it does. It just allows you to quickly or hopefully quickly, exchange a document between two business partners. On the other hand, web services integrate processes. How do web services integrate processes? Well, they decouple the users, and the interface of a web service can be described using an XML document. So in other words, what the web service does is it allows one computer to interact with another computer, not by exchanging data, but by basically calling methods, calling functions, calling operations on the other computer. Right? That's what the web service allows you to do. So it's as if one computer is talking to another computer, but now in a real sense, not just by sending data to the computer, but by actually getting responses, right? So you go to the other computer and you say, okay, this is what I would like you to do. And then the other machine will say, okay, here is what I can give you, and so on and so forth. And so with web services now, you have the ability on both ends to implement everything exactly the way you like it, and then just build an interface, meaning build kind of, the interface is the surface. This is what the outside world sees, right? And then just basically, based on the interface, the others can then interact with you, with your system. So for example, for a terminal, that would mean I could have a function that allows me to check the status of a container, right? And that would be implemented using a web service. So that means that one machine now, if there's a user on that machine that is interested in the status of a container, could then send a request through as a web service or through the web service protocol to the other machine, and then would get a response from that machine basically about the status of that container. So what happens now with web services, you are now in total control over what you want to share with your business partners, right? And you don't just exchange documents anymore, but you can now implement whole processes like that. And I'll give you some examples in a second. Hopefully that will clarify this a little bit better. So whoever uses a web service is called a consumer. He's the consumer of the web service. And the consumer, that's really the good thing. You don't need to know anything about the implementation. You don't need to know what things mean, nothing. All you need to know is how you can call that web service, right? And we are all very familiar with web services because anytime you go to the web, most websites, when you interact with the website, this is all basically a web service that you're using, right? When you go to Amazon.com, you order something or you look at products, these are all web services, right? You're interacting with their machine. You're basically calling some functions, and they control what you see, and they control what you can do. And they control how much data you can see, anything, how much data you interchange with them, everything. And if I'm a user of a web service, all I need to know is how do I interact with that service? In other words, I need to know the interface. I need to know what is available from that service. I don't need to know what actually happens behind the scenes, right? Like in the case of EDI, where I needed to know what each individual item means. I just need to know what does this system offer me, and then I'm using it as a consumer, if I'm interested. Right? And these calls, and this is also very important, are language independent. In other words, if you have one system that is based on a certain architecture and another system based on another architecture, they can still talk to each other. Right? It's not like you're locked into a particular language or anything like that, or an Apple cannot talk to an Apple server, cannot talk to a Linux server, cannot talk to a Microsoft server, or anything like that. This basically, in a way, unifies everything, right? So here is a picture, let's go through this, that describes what happens when you set up a web service. So the first thing is you have a provider. So somebody that is interested in basically offering a service over the internet. So what would the provider do? Well, the provider first has to make sure that others can actually find that service or can become aware that this service exists. So what the provider does is he goes to a discovery service and provides a function description and a web service description. So in other words, gives the description to the discovery service saying, this is the web service I want to provide. Okay? Now, the requester, somebody that is interested, comes in and says, okay, these are my criteria. This is what I'm looking for in a service. And then if this matches, the discovery service will tell to the requester, okay, here's the description of that web service that matches your requirements, that matches what you're looking for. So now, once the requester has that, he knows who is providing or wants to provide this service. So he can contact that provider And they can exchange some semantics. You know, they can exchange some ideas about what the meaning of certain things. So basically, they get on the same page, basically. And once they have done that, once they're on the same page, then each one of them goes about implementing what they want to do. In other words, given the semantics and the description of the web service, the requester builds a requester agent. In other words, builds a program. And the same thing happens on the provider side. The provider provides the semantics, the description, and builds a provider agent. And then these two entities, these are the ones that will actually be interacting. And unlike in the case of EDI, what we have here now is not just data exchange anymore, but what we have is that the requester can now basically execute procedures on the provider and get responses from the provider. But what the provider wants to share is all dependent on what the provider really wants to share. So the provider has total control over what he or she is sharing, right? It's not like he has to share certain things. If he doesn't provide this capability in the interface, in what the requester sees, then he can't do anything with it, right? I mean, the requester can't do anything. He can only really use whatever the provider makes available, whatever functions the provider makes available. And this now can all be done over the internet. Any questions about that? So, yes?
How does the system, this one, N4, assign meaning to EDI, which has no definition, no meaning as you described? Does the provider, does the requester ask for specific information and provider provides?
Well, I don't think you necessarily would want to use this to implement EDI. I mean, I think the idea would be, if you want this to be useful, to go one step further and to say, why don't we use this in a way to replace EDI, or maybe to open the box with EDI a little bit to include, for example, smaller customers like a terminal, right? So, for example, in the case of the ports, this could be the side of the terminal operator, right? The terminal operator could write a web service, provide a web service that would allow a truck driver or a small trucking company to go to a website to check the status of a container, for example. That's the example of a website, right? So now, instead of having to go to EDI to exchange information with the terminal, now we can exchange information through these web services. And once this becomes, established, the terminal could maybe go one step further and say, maybe we don't need to exchange our manifests anymore using EDI. Maybe we just do it using web services, right? Because it's just so much more efficient. And we control everything we want to exchange. And as you will see, I'll give you an example, it can also handle exceptions much better. If something unforeseen happens, a container is not available that was supposed to be there, then we can basically build an exception in here and say, okay, if the container is not there, we send a message back, the container is not there. And then the requester, let's say the shipping line, can then operate on this information and can say, so if the container is not there, let's try to do something else, right? So they get the response back right away, and then they can continue working based on that response, and it becomes an integrated process, right? So the processes get integrated with each other through this communication. So the idea would not be with this to kind of like you implement EDI with it, but to kind of get away from it, hopefully, eventually, and use this instead of EDI.
How does the transition take place then? Because I believe you said with XML and N4, you can utilize EDI. How does the transition?
I think that would be the hope, that basically, because these terminal operating systems have these web service capabilities already built into them, so in other words, you can easily generate and create web services and make them part of the operating system, so they would basically be hooked directly into the operating system, would have access directly to all the data that is available to the terminal, that basically that would make EDI in some sense obsolete, right? Because now you can basically communicate the same information, like for example a manifest, using web services instead of EDI, right? You just make it available. You just make it basically sit behind a procedure call, and then your carrier can send you the manifest through that procedure call, and then you can operate on the procedure call, send responses, and so on and so forth. So it has become this this fast interchange, which was much more 21st century than EDI. Right? Any other questions? Okay, so like I said, essential for web service, it has to be discoverable. So if nobody is aware of it, we can't use it, obviously. And you can access it. It can be computer-to-computer transaction, or it can be accessed through a browser. So it can also be human-to-computer. It can be both. It doesn't have to be necessarily computer-to-computer, but it can be also human-to-computer. And I believe it can be used to achieve integration with trucking companies, with rail facilities, with container depots, with shipping lines, and also for internal integration. So you can use web service basically for everything. Because all it is basically you just provide, it comes from the way people write code these days. When you write code these days, you try to encapsulate everything, meaning you hide all the unimportant information to a user outside, and you just let that user access it through some portals that you can control. And this is exactly what a web service does over the internet. It hides the information inside, and it lets others access the information through portals that you can control and that you can monitor. Right? And so instead of using EDI for doing this exchange, you use web services. So here's an example of a process integration. So let's consider what's called an EDI COPRA message. What is a COPRA message? A COPRA message is sent by an ocean carrier to a terminal, and it specifies which containers should be loaded on a particular ship. Right? That's what the message does. It tells the terminal which containers should be put on a particular ship, and it's a well-established standard. So it specifies the containers and the ship that these containers are supposed to be loaded on. So now let's assume a terminal gets this message, which is supposed to tell it which containers go on which ship. And now what happens is the one container in question has already been loaded onto another ship. Right? So in other words, the terminal is instructed, please load this container on this ship through this message. But in reality, that container, for whatever reason, has already been put on another ship, an earlier ship. So the question is, what should the terminal do? Right? Obviously, it was instructed to put it on this ship, but it's not able to do it, so it should do something. So should it discharge the container from the other ship if the ship is still there and reload it, or just leave it on the first ship? Right? The terminal would like to get an answer for that. But the problem is, EDI COPRA cannot tell the terminal what to do. That's not the idea of EDI COPRA. It's just telling you which containers go on which ship, and that's it. Right? You can't get an answer back through that message. And there are no other standardized EDI messages that can provide an answer. So there's nothing in the EDI standard that will allow you to take care of this particular problem. So EDI messages, this is a process, right? This is a process where we try to accomplish something, we realize there's a problem, so we would like to fix the problem, but to fix the problem we need an answer. This is a sequence of steps that need to be taken, so it's a process. EDI does not allow you to do this kind of integration of the process. Why is this an integration? Because the process involves both partners, basically, right? So you can use EDI to integrate the partners in this process. So it's just for document exchange. So you get higher cost, service failure, and then unhappy customers because you can't really fix it, right? The container will just be late or will be in the wrong place, what have you. Alternatives. Ideally, what we would like to be able to do is we would like the logistics agent to be able to log into his computer and to find the containers to reroute. Right? So it goes to his computer and says, okay, these are the containers I want to reroute. And then the computer will send a message in real time to the terminal's computer system. And the terminal's computer system can indicate in real time whether it's possible to do the rerouting and how much it will cost to do the rerouting. Right? And so the agent then sees the options and selects what to do. This is what we would like to have. This would be process integration, right? You as the employee, you go to your computer and you say, okay, because of customer needs, we would like to reroute these containers. Then you send a message to the terminal. The terminal tells you whether this is possible, in other words, whether the containers are still available or not. And if it's possible, how much they charge you for that. And then you get it back, you get that information in real time, right away. And then you can decide, is it worth it or should I not do it? So here is the summary of this. The shipping line would request a rerouting for a set of containers. The terminal will reply either the containers can be rerouted, the container cannot be rerouted, and it can be rerouted, or it can be rerouted at a cost of so many dollars. Or it may even say the container was not found. Right? And then the shipping line, the customer will say, will either confirm or cancel the rerouting of the container based on their needs, right? Based on whether they think it's worth it to spend that extra amount of money, or whether they say, well, no, maybe not. And once that has happened, once the terminal got the instruction, it can confirm or say, no, it wasn't possible, the rerouting of the container. And the shipping line then updates its own system with the new information about the new routing of this particular container. So this thing would require an integration of the rerouting process between shipping line on one hand and terminal on the other hand. And the same steps, some steps are done by each of the two entities' computer systems. And both parties can learn about the outcome simultaneously. Right? So that's really what is meant by process integration. But this requires real-time communication between the computer systems, and EDI has no facilities for that. But web services, on the other hand, do. This is exactly what web services are good at. This is what they are made for this type of integration. So the two parties could get together and could decide in advance, this is what we think may happen. So if you could provide us with some kind of capability in case this happens, that we could get answers for these particular questions, like for example, rerouting of containers, then we would be very happy about that. And so they can then integrate their processes. And now they are ready for these types of situations, right? They have a process in place that they can use in case something like that happens. And they don't need to go to the phone anymore, and their customers will be much more happy, and things will run much more smoothly and efficiently. So obviously, EDI is not really suited for that. You know, it was, like I said earlier in the overview, just designed a long time ago, and at that time, you know, there was no real-time communication between computer systems. It was just you send a message, and then later you interpreted the message, and there was just a time delay. And that wasn't really the intention of EDI. EDI was all about basically reducing the number of errors and enabling computer-to-computer communication. They didn't care about process integration. They didn't think about something like that at that time. But on the other hand, web services are, like I said, that's their strength. That's what they are made to do. That's their underlying philosophy, basically. So they are ideally suited for something like that, to achieve integration between disparate and autonomous systems. That's what they are designed to do. So why can't we just fix EDI to achieve the same thing? Well, you know, because EDI basically can't really compete with systems that have real-time communication, like where you connect it to the internet and you can send a message instantaneously. It's just not possible to compete with that. And it's still time-consuming and an expensive process, and you would have to basically code every possible exception into EDI and find a new standard message that would basically take care of that particular exception. So you would have to build in the whole process. And that explains why outside the Fortune 500, really very few companies are using EDI, because it's just too expensive, and it doesn't give you the process integration. What makes it so difficult and expensive? Like I said, lengthy meetings are necessary. And then usually when people get together, they find flaws in each other's implementation, they have to be fixed. So it's a very long process, the setup process, and makes it very expensive and inefficient. And like I said, exception handling. On the other hand, web services, you decouple users, right? You describe your interface as an XML document, so anybody can see what things mean, and you can understand that, and then you can use that XML document to build your own side of the story. You do your own implementation that reflects the interface that is provided on the other side, and you know everything you need to know. That's all you need to know. You don't need to know how it's implemented or anything like that. It's really you're just a consumer. I think that's a very apt name for this kind of thing. You're just a consumer. You're consuming the service, basically. You don't worry about what is behind it, how is it implemented, what needs to be done to implement it, anything like that. You don't need to be concerned at all. You just use it. It's like going to the website of Amazon.com and looking at some product or making some orders. You don't need to know about the implementation. I said that. You just need to know the interface, how to interact with the service. So we could use web services now for all these integration processes. We could use it for integration with trucking companies. For example, we could make the container status available as a web service, right? So as a web service that the terminal provides, users can go, authenticated users, authorized users can go to a website that the terminal provides and can basically look at the status of a container. A dispatching system could access a web service and check the status of all required containers, right, to see whether they are all available, when they will be available, and things like that. You could integrate a near-ports distribution center, warehouse, and yard management with the terminal's computer system, so they could interact with each other. You may be able to achieve just-in-time delivery for the containers, optimizing and reducing the required yard and the warehouse space. And you can integrate also outside trucking companies using web services, right? So you have lots of flexibility, and it's really up to you, if you're the terminal operator, how much information you would like to share. And if you want to share information, then you build the interface. You basically decide what you're going to share and how you're going to share. You can do integration with rail facilities through web services. So if you have a near-dock rail facility, you could have integration with the loading and discharging of containers to and from a train, and integrate that with the terminal's operating system. And so that you basically, you have absolute control over the location and status of a container at all times, basically. And you can provide this information to the rail operator just in time when the rail operator needs that information. So they are ready for it, and they can build their trains more efficiently. Container depots, right? Container depots take care of empty containers. So if you have need for empty containers, you could use web service to inform the container depot, we need empty containers, or we have too many containers, we want to send you some containers, things like that. And then the systems can interact and can exchange information, how much more space they have left. Or the depot can use that information and get from the terminal to decide how to allocate the containers, where to put them, and so on and so forth. Integration with shipping lines, you can do. These are the primary customers of a terminal, right? So basically the terminal basically just interacts with the shipping lines or the carrier's customers on behalf of them, right? So basically the terminal should be aware of the business rules of the shipping line, because it's kind of the agent of the shipping line when it interacts with its customers. So if you wanted to use EDI for that, you have a never-ending stream of EDI messages, because for every little thing you need a different message, and for some things you may not even have a message, and no flexibility. On the other hand, if you use web services, it's cheaper and more efficient, because you could just, as the shipping line, specify which data you need to have access to apply your business rule, right? So this is what I need to know, and then I can apply my business rule. And so if an event occurs at the terminal's computer system could send a message to the shipping line, and that could be done using web services. So there's an event at the terminal, you send a message to the shipping line. The shipping line gets the information, and then the shipping line can apply its own business rules on this information and then return a response and say, okay, this is what we want you to do. And when you do that, you continue processing the event, and there's no interruption basically. It's one smooth process. So the terminal doesn't even need, yes?
I think we got like 5 more minutes.
Yeah, I'm almost done. Okay. So the terminal does not need to know the business rules of the shipping line, right? And you can change them on the fly anytime you want. So that's also possible. So you don't need to communicate that. If you want to change your rules, you want to change your price, you want to change how you operate, how you deal with your customers, you can change that at any given point in time, because it's all part of your implementation. It's not part of the interface. Okay? And the costs will be reduced, obviously. No need to set up any kind of shipping line rules or anything like that. And you can either reduce the cost of EDI, or reduce the amount of EDI you need to use, or totally eliminate it. I think that's basically along the line what hopefully or likely to happen. And you can ensure that the rules are enforced exactly the same way in all your terminals, because it's just one place where they all have to go if they want to do something like that, and then that place will decide how to do it based on how you said you want your rules to apply. So if we would have a port communication system, we could also use web services for the different agents to interact with a port communication system. But this is just an aside. I don't want to go into details here. So to summarize, what are the recommendations? We talked about XML EDI. It's the cheapest, but it doesn't really remove the disadvantages of EDI. It's really just a patchwork solution. I also talked about EDI INT. You need to have a system that can support it, and you shift the problem of multiple EDI standards just to XML. So it doesn't really, again, you don't really get a lot of bang for your buck. You're really just pushing the problem along. The problem meaning the disadvantages of EDI being so bad at exception handling and just being so cumbersome to implement. On the other hand, I believe, or we strongly believe, that web services are the most promising approach, given the bilateral information model that we have at the ports, where basically these individual agents are just interacting with each other in a bilateral manner. And so web services are ideally suited for this particular situation, because they allow us to integrate processes. And ownership over data, which is always a very sticky point, is not compromised. Right? You still control what you want to share. And you can be absolutely sure that this is the only thing that is shared. There is no way for anybody to find out anything else about what you're doing. You don't even have to share your business rules, right? They're all staying behind the interface, behind what a user would see. The user can just get the information that you want to provide to that particular user, nothing more, nothing less. And so if already a terminal has installed one of these expensive operating systems, I think web service is really the way to go, because these terminal operating systems already have these capabilities. So if you're not using them, it's just silly. It's mind-boggling to me not to do it. And I think this is the way to go, and I think it would greatly improve efficiency and communication at the ports. Thank you. Questions? Yes?
Is anybody using any kind of web services at the port?
As far as I know, at this point, no.
How about like around the world?
I mean, let's say this way. Let's say, for example, if you have, you can make appointments, right, at the ports. So if you implement your appointment system online, that's basically an example of web service, right? Yeah. So there are some initial steps in this direction, but not. I don't think at the large scale of having computer-to-computer interaction. I believe in Asia they are a step ahead of the United States. They are a little bit more open to these new technologies.
Do you think the reason is because they're afraid of security, or is it simply they don't have the margins are so low they don't want to spend the money?
I believe it's several things. One thing is the culture, right? They have just been doing it for so long like that, and it seems to be working, even though it costs them a lot of money. But it's like it's a cost that they can just write off in a way, right? And so they know this is how much it's going to cost, and so let it be like that. Secondly, it's maybe there are some concerns about security, but there really shouldn't be, because you can encrypt this information very straightforwardly over the network. So yeah, but I agree that may be one of the reasons.
So is labor management issue also?
Labor management may be another thing, because you have all these EDI departments already there. These are hundreds of people working there, and you would have to reassign them, right? So
retrain.
Yeah.
Any other questions? All right, thank you very much.